So cut off the borders and cut out every box. So in order to define simple harmonic motion, I'm going to actually start by discussing periodic motion. Okay? Periodic motion. When I say periodic, what do you think of? Like a period of time. Periodic is any repetitive motion. Okay, so periodic motion is any repetitive motion. Something that's periodic is something that happens again and again. Periodic motion, any repetitive motion. Give me examples of a repetitive motion. Out on the swing, playing as a kid, out on the playground. Great example. You go back and forth and back and forth. The water cycle. Very good. The water cycle that you learned in science. Okay? Water gets evaporated and then it becomes precipitation and it goes down the river into the lake and evaporates again and it cycles through. Roller coaster because it goes through the same course over and over again. How about, think about this, the name of a bicycle. The wheel. Any sort of wheel or tire goes around and around and around, a very repetitive motion. Tennis ball. Goes back and forth, then back and forth, both sides of the court. So back and forth, then back and forth. Okay, so a tennis ball. All right, those are all repetitive motions. So go ahead, glue that in. Simple harmonic motion is any periodic motion that is caused by a restoring force. Go ahead and glue that in, leave a little bit of space. So simple harmonic, it's often called simple harmonic motion, okay, rather than harmonic motion. I'm not quite sure why they call it simple, but sure. Simple harmonic motion. Now, to understand the definition of it, we have to understand periodic motion, which we just did. Periodic motion, any repetitive motion, that is caused by a restoring force. So, what's the definition of a force? A push or a pull. A restoring force is a push or pull that tries to move an object to an equilibrium position. We combine these two definitions for periodic motion restoring force to create the definition of simple harmonic motion. So you could read the definition for simple harmonic motion as any repetitive motion that is caused by a push or a pull that tries to move an object to an equilibrium position. And out of all of this, the biggest key word, equilibrium position. The whole idea of whether or not it is actually a harmonic motion depends on if there is an equilibrium position for the object. The best way to understand harmonic motion and what it really is to look at examples. So let's look at some examples of simple harmonic motion. The most classic example is a pendulum. Go ahead and take this. Go ahead and glue in the picture of a pendulum. Try and use as little glue as possible because we're going to write on it. These are the different parts to a pendulum. We have a frictionless point. Okay? We've talked a lot about friction. The reason for the frictionless is because then we actually have pure conservation of energy. Then it says here a massless rod. What on earth does that mean? Massless. All right? That it has no mass. Is that possible to have a massless rod? No, that's not possible. So when you go to build a pendulum, the goal is what? That string, this is usually string, all right, is as thin and light as possible, as minimal mass as possible. Does that make sense? We don't want to use a big, thick, metal, heavy cord if we can avoid it. We want something thin, all right? Rod, ideally it would be something that's rigid, but that's usually not a problem. All right, the thing at the bottom, they call it a bob. But notice it is massive. The rod was massless, the bob is massive. What does massive mean? Huge. It has lots of mass to it. Okay? So we want the string to have as little mass as possible. The thing at the end, the bob, to have as much mass as possible. Okay? And then we have here the bob's trajectory. All right. We've used the word trajectory before in class. Do you remember where?
Yes, from the projectile motion.
Projectile motion. If you turn quickly to page 19, projectile motion. What is the trajectory? It's the arc. It's that path that the projectile travels through in the air. Okay? When it's a projectile that has a parabolic shape. Not true with harmonic. It is not parabolic shape. But this trajectory is the path that the bob travels through in space. Okay? Does that make sense? Now, in this pendulum, it has an equilibrium position. Okay? Equilibrium position. The highlighting color you use for equilibrium position, you're going to highlight in the picture that dotted line there and highlight equilibrium position. What does equilibrium mean? It doesn't really necessarily mean equal. It means balanced. All right? When it's all balanced out, it's at rest. It's stopped. It's going to be right there. Okay? It's not to one side. It's not to the other. It's right in the middle. Okay? Equilibrium position for a pendulum. Glue it in. Just a little bit of glue. Okay? This is traditionally called a spring pendulum, properly called a spring mass system. Either way, it's still the same thing. So imagine a spring being hung from the ceiling and you put something heavy on it. Some mass, some bob at the end. Okay? And you just let it hang there. If I take the bob off, what's going to happen to the spring? It would go back up. Okay? But if I leave the bob on and I pull it down to that position and then let it go, woo! It's going to go up and down and up and down and up and down, right? Just like a pendulum goes back and forth, this one goes up. So in a spring mass system, the repetitive motion is that up and down and up and down and up and down. Okay? Now, the equilibrium position is when it's just hanging there. Okay? Not when it's all scrunched up, that's when it's at its highest. When it's all stretched out, that's at its lowest. But when it's just in that nice, just hanging there position, that is the equilibrium position. So go ahead and label that. Equilibrium position. And that's the basics of harmonic motion. Okay, to understand what it is. It's a repetitive motion that has a force that tries to bring it to an equilibrium position. Okay? And we have got gravity as our force here in a pendulum trying to bring it to right there. It goes up, gravity brings it down. It goes up, gravity brings it down. Gravity is that pull that tries to move it to that position. Same here. Gravity tries to pull it to that position. Okay? There's some force of the spring pulling it up and gravity pulling down. That balanced out. That's our equilibrium position. Okay? Harmonic motion.